We had a few questions from chapter 11, question 24. Question 24 tells you that we have 150 grams of a compound, and that's actually important information that they tell you it's a compound because they're talking about our Van Hoff factor. So if it's a compound, it's a molecular substance. Our Van Hoff factor would be 1. So you add 150 grams of this unknown compound to a solution of 425 milliliters of benzene. And there's a change in the freezing point. So that's our delta TF of 18.6 degrees Celsius. So the freezing point goes down by 18.6 degrees Celsius. And then that we know the freezing point constant for benzene is 5.12 degrees Celsius per molar. The first question they ask is, what is the molality of this solution? And you might not think that we have enough information to answer that, but we really do. If we take a look at the equation, we know change in freezing point, delta TF equals a negative Van Hoff times my freezing point constant times our molality. We know our delta TF, we know our Van Hoff factor, I, and we know our freezing point constant. So we can find molality. My change in my freezing point is 18.6 degrees. Our Van Hoff factor is 1, and our freezing point constant is 5.12 degrees Celsius per mol times molality. Molalities are unknown. So we're going to divide both sides by a negative 5.12 degrees Celsius per mol. Right, degrees Celsius cancel out, and we're going to be left with a molality of this solution of approximately 3.63. So that's part A. Part B, they ask us how many moles of this unknown do we have? And we know molality, right? Molality is moles per kilogram of solvent. So for part B, we have to find how many kilograms of solvent do we have? Well, we know we have 425 milliliters of benzene. And they tell us that the density of benzene is approximately 0.877 grams per 1 milliliter. So we're going to multiply, milliliters cancel out. We have approximately 372.7 grams of benzene. So the next step would be to convert that into kilograms because we need to know how many kilograms of solvent we have. So 372.7 grams, we know there are 1,000 grams in 1 kilogram. So we divide by 1,000, 0.3727 kilograms of solvent. Now we can find out how many moles because we know molality is 3.63 and molality is moles per kilogram. And we want to find moles, we need kilograms to cancel out. So I need to have kilograms on top. I'm going to multiply by 0.3727 kilograms over 1. Kilograms cancel out. And we have approximately 1.35 moles of the unknown. So that's step A. Step B. Now we want to find the last question. We're told, what is the molar mass of this unknown? And we know we have 150 grams, and we know how many moles that is. Molar mass is usually in units of grams per mole. Well, we know we have 150 grams of that sample, and that represents 1.35 moles of this substance. So if we divide 150 grams, which is our total mass, by how many moles that mass represents, we should be able to come up with a molar mass of this substance. So 150 divided by 1.35 will give us 111 grams per mole. So this is a really good question. There's multiple steps. We have to do the Van Hoff calculation to find the molality of the solution, turn molality into moles, so find the mass of solution in kilograms, and then use that to find the molar mass of this unknown. Other things that we had to pick up along the way, as I pointed out, the first step, what really made the first step tricky was that they identified this as an unknown compound. Based on that, we would say that the molar mass, the Van Hoff factor, should be 1. They don't talk about it ionizing, right? So we would just have a Van Hoff factor of 1. We'd have this one unknown in solution. And that helps us find the molality, and then from there, find moles and the molar mass. So hopefully that helps with question 24 from chapter 11 homework.